So to finish our problem, we want to find the force due to the bolt that has x and y components. To find the force due to the bolt, we'll go to our equilibrium in the x and y direction. So the sum of the forces is mass times acceleration in the x. It's in static equilibrium, it's not moving, so that has to be 0. So we add up all the forces in the x direction, minus t times cosine theta. Theta was the angle between the wire and the post, that was 30 degrees. Plus the force of the bolt in the x equals 0, so the force of the bolt in the x equals t times cosine 30 degrees. Let's put in the t that we just found, 176.6, times it by cosine 30. We get an x component of the bolt force to be 152.9 newtons. So there's our x component. Let's also find our y component. Not only is it static in the x direction, it's static in the y. So the sum of the forces in the y is mass times acceleration in the y. That's going to be 0 because it's not moving vertically. So t sine theta minus mass of the sine times g minus mass of the post times g plus force of the bolt in the y equals 0. The only number we don't know here is the force of the bolt in the y. So force of the bolt in the y equals mass of the post times g plus mass of the sine times g minus t times sine 30 degrees. Let's put in our numbers here. The mass of the post, remember, was 10 kilograms. So we have 10 kilograms times 9.81 meters per second. We multiply those. Then we add on the mass of the sine times gravity. And the mass of the sine was 5 kilograms. So 5 times 9.81. Last, we want to subtract t times sine 30, and the t was 176.6 newtons. So minus 176.6 times sine of 30 degrees. Gives us a force of the bolt as 58.8 newtons. 58.85, so that would round up to a 9 newtons. So we're almost finished. That's the x and y components of the bolt force. Since it is a force, we have to express it with direction. We can either do polar notation with magnitude and direction, or we can write it in unit vector notation. Let's go with that way since we already know the components. So there's our force due to the bolt.